This is the spiky potatoes experiment. So you're going to need some potatoes to use. Now I recommend slightly larger than normal, so something you can hold or have right in front of you, which is easy to use. I'm not going to say right any more than that because you're going to be seeing what I'm doing. I'm actually going to use this one, all right? So we'll leave those two there, just to show you there's more than one size. So there's the potato I'm going to use. Now what I want you to do is get two milkshake straws, two milkshake drinking straws. So I'm just going to pull two from here, okay? These are actually bendy ones, which are not ideal for this experiment, but I won't use that end. You'll see what I mean. So there's the bendy bit. I'm not going to use that in this experiment. I'm going to grip my hands around that bendy bit and I'll use the other end, okay? So pick one of your straws. If it is a bendy straw like this, hold it in the same way as I've just described. Wrap your fingers around. Don't squash it up so it all gets dented and squashed. Just gently wrap your fingers around, but you need a firm grip, okay? And what I want you to do first is just go to somewhere, doesn't matter where, on a potato, and slowly push the straw into the potato. Slowly, slowly, slowly. You can use as much force as you want. You can push really hard if you want, but go slowly, okay? So slowly, 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 and see what happens, okay? Then I want you to use a new straw. New straw. As best you can, hold it in the same way. This time, somewhere on the straw, I want you to put it down and go as fast as you possibly can. So you might want to do a sort of a practice swing first, because you want to line it up wherever you want to hit it. Line it up first like that. Do it a few times. You want to do it nice and straight if you can, as straight as you possibly can, straight down in, and do it nice and fast as you can, right in as fast as you can. Notice, by the way, I'm on this sort of cutting board. Something nice and strong like that and a good strong surface around it. The kitchen's a good place to do it, but this will work here. Anyway, off you go. So let's see what happens when I do it. Okay, remember, slowly, slowly first time. I picked up the same straw as I had before. I've gripped it nice and firmly. I don't really want to squash the straw, but I'm just gripping it firmly. Let's push it in. I'll go for the middle, say. So mine just bent over. I made a tiny little nick in it somewhere. You can just about see a little round circle. You might have gone in a bit further. Let me try again. See, not much good, is it? It normally just buckles up. That's probably what happened with yours. It'll bend like that. Okay, now, so let's try it with the other straw. Remember, these, by the way, were taken from the same pack. I hope you're using two straws that are the same. I know they're a different colour, of course, but otherwise they're the same sort of straw. They came from the same pack. So same sort of straw. Let's do it again. Remember, this time you've got to do it as fast as you can. So I'm going to take aim. Let's turn it back to the same side. Why not? Use the same side. Take aim, fast as I can. Now look, this time I've stabbed well in, okay? So here's where the spiky bit from the experiment comes on, spiky potatoes. Now let me pull it out. I'm gonna hold it, I'm gonna pull it out and put my thumb where it's touching. See how much went in? Oh gosh, a bit tough. So it went in that far. Amazing, look at that. Stuck right in that far. Now, how about doing it a slightly different way? The way I'm going to shoot, I'm going to hold it now because I want to do it lifting it away from the table, okay? I'm going to wear a glove to protect my hand just in case I miss. So this is a garden glove, okay? So I'm going to wear it on this hand. Hope there's nothing living inside this. I got this out of the garden earlier on. And I'm going to get a new straw, new straw, new straw. These are all from the same pack, remember? And I'm going to hold it like that. And I'm going to go to stab near the end, okay? Let's see, because sometimes it's easier for me to do it this way, but there's something else I'm hoping I'll be able to show you anyway. But let's see what happens. Ready, take aim. Wait, let's try another one. Let's try another one. Getting a bit spiky now, isn't it? Now you can see where the name's coming from. Let's go for one more. And of course I'm holding this. Please, if you go for this way of doing it, do find something to protect your hand. I really do recommend you do it that way anyway, because then there's no problem at all. But notice, I've done this lots of times, even I'm protecting my hand, because even I can make mistakes, even though I'm quite an expert at doing this by now, to be honest. Now all of them have gone well in, haven't they? Amazing. So, how is it that when we get one straw and push it slowly but firmly, remember I said you can do it as hard as you want, so you could have pushed really hard, but when you did it slowly, I'm sure you had the same thing I did, but your straw just buckled up. It might have gone in a little bit, but it buckled and bent. But then when we did it, the same straw, or same type of straw, and we did it really fast, as you can see, you can stab it. Now some of you might have done it, and it might have actually gone right the way through. Quite often it does for me. It will depend on, say, how hard the potato is, to be honest, and this is a pretty firm, hard potato. But sometimes I do it, it literally comes out the other side. So I can do that, I've done it loads of times. It will peep out the other side, and some of you may have found this out. So when you did it nice and firmly, it comes out the other side. Now I'm going to suggest another way you might do it in a minute, which might do that anyway. But that's the way I'm doing it, where I'm just gripping it and I'll ram it in like that. So let's think about it. We need to think about a property of materials or any object called inertia. Now inertia is really the laziness of something to move or change the way it's moving. So for example, if we've got something that's still, like our potato, we need quite a lot of force to make it change what it's doing or to change its shape. Okay? If it was actually moving through the air, like if I chucked it, I won't do that right now, but if I did chuck it and it was going through the air, it's going to take quite a lot of force to stop it or to make it change direction. So in other words, inertia is something to do with the difficulty or the amount of force you need to get something moving if it isn't, or to change the way it's moving if it is. Now, come back to our potato then. Our stationary potato, and we use the straw. When we push the straw into it, and we go slowly, of course this buckles up. The inertia of the potato is more to change its shape than the inertia of the straw. So the inertia of the straw was less, and so that's why that buckled first. So when we went to put it in, we didn't need so much force to change the condition, if you like, or the way this is doing it, whatever it's doing, and it buckled, okay? So that's why. Now, when we started going really fast, and let's get a straight one again, and do it really fast, I'm just going to do it slowly, but if we did do it fast, this time, this is going much faster, of course. Now, the amount of force that hits that surface is something to do with how fast that goes as well. Even though I did tell you, you can push it as hard as you want, even when you're going slowly. You could have been pushing really hard, using tons of force, but when you do it really fast, because you're going much faster, more force impacts and hits that surface. And it's so much more this time that, believe it or not, things have swapped around. Now, the inertia we need to change the shape of that potato is enough. It can actually deform quite easily, and it goes right in because of the massive increase in force that we were using because of the speed of impact. So the higher amount of force was enough to easily overcome the inertia of the resisting potato, and so it goes straight in without too much problem, okay? And of course, this is moving so fast that it doesn't have time to deform down the length of it. And the other thing you want to bear in mind, if I get one more, is I know you can't see close up here, but with your one, have a little look. But of course, you're using a very thin edge. The actual impacting bit of the straw, the bit that actually goes into the potato, is very thin. It's not like the whole thickness. You haven't got a great big fat tube, solid tube trying to push the potato out of the way. You've only really got a thin edge. So it's almost like acting as a blade, an edge on a knife, say, but a circular edge, cutting into the potato, and that of course helps things out. So that's how come you can drive a straw into a potato. Some variables. Okay, well, I've hinted at a few to do with, say, for example, the speed of impact. Now, I told you to do it very, very slowly, but use as much force as you want, but just go slowly. And then I said do it as fast as you can. I wonder what's the slowest you could do it, and it'll still go in with no problem. Because I did it pretty fast, and hopefully you did too. But I wonder if you could have done it some more slowly. So try that. What about, you notice I told you just grip your fingers like that. Another way of doing this would be to put your thumb over the top like that and seal it like that. Now I'll give you one little clue about this. When you do it that way, as you strike into the potato really fast, you're going to be squashing the air that's trapped inside. Maybe you're not going to let it out from this end. So as you do that, you're going to squash the air in here. And when it gets squashed, it builds up pressure, becomes more pushing out all sides in the straw. And that makes the straw a bit more stiff and a bit more rigid. So there's a clue. So if you put your thumb over the top, do the same thing, you're going to trap some air in. The pressure's going to go up really fast, and that'll have the effect of making the straw a bit more rigid. What do you expect that would do? What about different sized potatoes? I mean, I've given you some clues by having them at the start. Do you think that makes any difference if you use different sized potatoes, or will it only work on a big one like that? What about bigger? Of course, potatoes get bigger than this, so try a bigger potato. What about using thinner straws? I've said milkshake straws for this one, haven't I? We've used milkshake straws. I wonder if you could do it, particularly if your hand's smaller than mine, if you use an ordinary thin straw. I wonder if it'll still work with the thin ones. So you'd have to repeat it the same way, so do it slowly with a thin one and then really fast with a thin one. Do you think that'd make any difference? I'll leave you to figure out a few more variables.